Is a presentation for final project for the Coursera course managing ML projects. For this project, I chose a problem when service providers rely on equipment installed in the customer homes, and because this equipment fails, this has negative impact both on customers and on the service provider. So I believe that we can use machine learning to predict those failures and proactively replace those devices so the customer would never get their service interrupted and they enjoy watching the TV or good access to the internet service. First of all, there is a problem when customer get their service interrupted. They become unsatisfied and they can leave to another service provider. This negatively impact company's revenue and customer opinion about the company. Machine learning can help to solve it because all the devices connected to the service provider backend system, and they provide lots of data points about performance of the service. If we collect this data and connect it with information which device are most likely failing, we can build a machine learning model which would predict which devices are most likely to fail within the next several months. This information can be used by service provider to replace those devices proactively. In result, customer would never get their service interrupted and they would never consider to leave to another service provider. At the same time, companies can increase customer satisfaction and they would avoid customer churn. Target user for this machine learning application would be companies who manage the fleet of equipment at customer homes. Example, internet providers or TV service providers. Actual users who would use that would be employees in the customer service department. They can run this report to get list of devices which are most likely to fail over the next months or so, and they would need to work with service technicians who visit customer homes to replace that equipment. And this period it can vary, so we can define whether we want to replace devices which are most likely to fail within next month or maybe 2-3 months. We can define it later after experimentation. The problem is that the failed devices at the customer home require technicians to visit the customer to replace the devices. So if we don't proactively replace the device, then the device can fail eventually, and customer has to call to the service provider, book a technician. So it usually takes several days before technician can come to the customer and replace equipment. So customer would need to wait for several days, and during this time he can decide to switch and join another service provider. And because customer left with a service, they become unhappy in this critical situation. So today, as I described, we don't usually service providers don't replace equipment proactively, and they have to wait until equipment actually fails. If our solution is successful, then the devices would be replaced proactively, and the average customer satisfaction level would be improved, because we would avoid the situation when customer become unhappy with their services. For outcome metrics, we can use Net Promoter Score, which we would measure, and this Net Promoter Score would include customer who has their service interrupted, and because number of those customers decrease, our Net Promoter Score would increase. Also, we can measure monthly customer churn, and this would be ultimate metrics because it directly affects our revenue. Although we would have to measure this over a longer period of time, because even if we implement this solution, it will take some time before we see the effect. And for output metrics, we can use classical uh, metrics for classification model. It would be precision, recall sensitivity curve, and precision recall curve. Potential constraints would be that it's difficult to confirm if the device we replace would actually fail. So in our solution, we uh, we are planning to replace devices which are still working, and we don't know for sure if they actually would fail. So once by the time we replace it proactively, it still works, and there is no way to confirm if it fails after 2 or 3 months. So the only way would be to measure average number of devices which fail and compare it with historical data. And some relevant factors which we can use to for our machine learning model would be some performance parameters of the device. Today, service provider implement different services when the device measure Wi-Fi, quality TV, health data, and so on. And also there are various technical parameters monitored by service provider behind the scene. So it is not visible to users, but even today, service provider try to measure the quality of their services. We can use this data, match with historical data which devices has failed, and we can build our machine learning model based on this. For the solution, we would build application which generates weekly reports. This report would be a list of customer who has devices which are expected to fail. On the backend, machine learning pipeline would collect the data about each connected device performance and feed the data in the model. Then machine learning model would generate predictions about the devices, and this report would be used by customer support agent to book technicians to go and replace those devices. For the experiment, first we can build application without actual machine learning model, and we can use some heuristics. For example, we can use age of device as a prediction that this device most likely to fail, and we can generate the list of devices which are older, let's say, than 5 years. Then we can present this list to customer service agents so they can try and book. This would help us to discuss our business process with future users. And once this would be acceptable, the performance of this part of the application, we can actually start building machine learning model, try to fit the data and compare with our heuristics, which is basically based just on the age of the device. And once we build our machine learning model, we can monitor its performance by comparing uh, historical data, how many devices failed in the past and how many failed devices actually now in the fail actually in the field. For the machine learning system, we can use cloud because all the devices are already connected and the control and monitoring happening in the cloud, so we can easily get access to that data. I think offline learning should be fine because uh, the model doesn't need to be updated often because we still use the same devices for prolonged period of time, and we can update the model maybe once a month, for example. And then batch prediction would work perfectly in this situation, and it would align very well with the business model. So once a week, for example, agents can generate this report, and then they would have a list of batch, in our case, of the customers who has devices most likely to fail, and then this list can be used by agents to book technicians to go and replace those devices proactively. Potential risk once our model is deployed into production would be a drift, which can happen when a service provider starts installing new devices, and by new I mean new model of the devices, and most likely these new devices, this new model, they would have different life expectancy, and we would need to retrain our machine learning model to accommodate for this new type of devices. And this is all for this presentation, and thank you for listening.